I'm going to create a Kubernetes cluster using AWS EKS. Now, AWS EKS is a managed Kubernetes service offered by AWS. At a high-level overview, this is how the architecture looks like. So the Amazon EKS have two components, just like we have on the Kube ADM setup. We have the control plane and we also have the worker node or the compute plane. However, the control plane processes like the Kube API server, the etcd, the scheduler, the controller manager, all of these master node components are managed by AWS. They are all abstracted away from you and you don't get to see them or even, configure them by yourself. The only thing that you can do is that you can configure monitoring and logging to get information from them like authentication, scheduler, those kind of logs you can get, but you cannot configure them, neither can you see them. And also, those master node processes, right? All of them runs on AWS managed account and also on AWS managed VPC. Remember that VPC reside on an AWS account, and that AWS account where the VPC is residing on is managed by AWS itself. If you ask me, that makes it really, really secure because you cannot, hack it unless there's a misconfiguration on your side before an attacker can gain access to those master node components. Now, let's turn our attention to the worker node. Now, the worker node processes or the worker node itself runs on your own VPC, which means you can create your own VPC and then allow your worker node or deploy your worker node on that particular VPC. Now, we're going to see how everything is going to look like as we progress through this demo. What are the steps that we need to take in order for us to create the AWS EKS? Now, we're going to see all the steps. Now, the first thing that we need to do is to create an IAM role. Remember that the AWS EKS, whenever I say the AWS EKS, I'm referring to the master node component itself, which is the one managed by AWS. So in order for the master node component or the AWS EKS to communicate with our worker node, we need to create an IAM role with some certain permission and assign it to the AWS EKS in order for the AWS EKS to create resources or manage our worker node. Remember that in an AWS account, by default, nobody have access to it unless you have been explicitly granted access in order for you to create resources or interact with an AWS account. That's exactly what is happening here. In order for the AWS EKS, which is running on AWS managed account, in order for that to create resources on our account, we need to add that permission to grant them that privilege to interact with our own AWS account. And that is why we need to create that IAM role. Then after that, we need to create VPC. All compute resources on AWS runs on a VPC. That is not different from our worker node. So our worker node really needs to run in a VPC. But mind you, the VPC that you need to create for your AWS worker node or your EKS cluster must meet some certain criteria outlined on the AWS documentation. We're going to see some of them as we progress through the course. Then after that, we now need to create the EKS cluster control plane, which is the one that is managed by AWS. Now, the reason why we create the IAM role first is because we need that before we can create the EKS cluster or the EKS control plane. And also, we also need the VPC before we can also create the EKS control plane. So in the process of creating the EKS control plane, you need to specify the IAM role and also the VPC where the EKS cluster needs to run. Then after that, we need to connect to the cluster to ensure that everything is in order. So we're going to use the kubectl command line utility to connect to our cluster and to see what is currently running. Then after that, we need to create another IAM role for the worker nodes. Now, mind you, our worker nodes are EC2 instance, and we need to create IAM role and attach it to those EC2 instance. Now, why do we need that? Number one, whatever thing that we're going to deploy on those nodes might need to interact with our AWS account. For instance, if you deploy an application or you deploy a pod that needs to pull image from AWS ECR, right? So because of that, if there's no IAM role attached to those nodes, those pods or our deployment wouldn't be able to pull those images from AWS ECR. And also the EC2 instance need IAM role because they need to also connect to the EKS cluster, and they need some setting permission. Without those permission, you're going to have a hard time trying to connect to the cluster. Now you're going to see some of the reasons why these IAM roles are really important. But for now, just stay with me and flow. Now, after that, we also need to now create the node. Now, this is the node where the worker processes, or this is the node where our applications are going to be deployed. Applications are not deployed on master node. They are deployed on the worker node. Then after creating the worker node, we need to assign the IAM role created in step 5 to the worker node. And AWS, we call them node groups. And we're going to see different ways of actually running our applications on worker nodes. We have Fargate, we have managed node group, we also have self-managed group. But in this demo, we're going to be taking a look. We're going to be using the node group itself. Then after that, we're going to create a sample application and then test our setup to see if everything is working. And lastly, we can now expose our application to users by using the AWS load balancer controller as an ingress so that external user can access our application. Now, these are the steps that we need to take in order for us to get this setup up and running. But before going into the demo, please, if you are coming across my channel for the very first time, please do well to hit the subscribe button and also share with your friends. Now, if you like this kind of video, I have loads of them on my channel. Go through them, watch them, and also make sure you are doing hands-on. And if you have any question, please do well to leave them in the comment section. I'll be glad to answer each and every one of you. So without wasting your time, let's jump straight into the demo. I am logged into my AWS account, and I'm going to head over to the IAM role section to create the IAM role. So we're going to search for IAM role and click on it. Head over to the role section and click on it and click on create role. Now you're going to see different identities that you can attach the role to, but we're going to click with the AWS service. Click on the drop-down menu and search for EKS. You're going to see the EKS service here. Click on EKS and scroll down, and you're going to see different identities or different services under the EKS that you want the role to be assumed. Because whatever thing you're going to create here will be the service to assume that role. So you need to be very careful and be very specific as to what identity that need to assume that role for operation. So if you look at it very carefully, we're going to go with EKS cluster because this is the main thing that we want to create and not EKS service. So we're going to select the EKS cluster. Then after that, scroll down, click on next, and you will notice that immediately you click on the EKS cluster, you're going to see you're going to see the permission automatically assigned to that particular, service. Now, if you scroll, you're going to see all the permissions that are needed for the EKS cluster to work. You're going to see all of them here. You can have a look if you want, right? Just to get an idea of what is actually happening under the scene. So after that, click on the Amazon EKS cluster policy, which is already here. But if you don't see it on your own side, right, you can just search for it on the policy page. So after that, click on next, and we're going to give it a name. We're going to call it EKS. I'm going to call it EKS IAM role. Then after that, you're going to see the description automatically assigned to it. You just leave it as it is and click on create rule. Now you can see that the rule has been created successfully, which is the step 1. Now the step 2 is for us to create the VPC. Now before going into creating the VPC, I just want you guys to have a look at what the VPC requirement is for EKS. So you can search for VPC EKS requirement, search for it, and view Amazon EKS networking requirement for VPC. Then click on the first one. If you scroll down, you're going to see most of the requirements. And the notable one that I want you to take note of is the first one is your VPC must have sufficient IP address available for your cluster. Because in the EKS cluster, all your components that need a VPC are going to be assigned IP addresses from your VPC. So as such, you need a huge pool or large pool of VPC available. Otherwise, you're going to have networking issues. Then also, a notable one is that you need to also make sure that your VPC CIDR block does not conflict with any other network that you're going to be peering with your VPC. For instance, if you want to pair other VPCs to your AWS EKS VPC, you need to be very careful that the CIDR block does not conflict. And also, they don't overlap. And also, another one is that you must enable DNS name and DNS resolution support on that VPC. Otherwise, it's not going to work. So these are some of the requirements that you need to follow. I'm going to show you guys as I progress through the demo. And if you just want to read about it, I'm going to leave the link of this on the video description so you can have a look if you want. So let's go back. Now, let's head over to the VPC session to create our VPC. You click on VPC, click on create VPC, go to your VPC. Click on create VPC, and to make this very fast, we're just going to use VPC and more to make it really, really fast. And also, we're going to give our VPC a name. We're going to call it EKS cluster. Just call it EKS cluster. And our CIDR block, we're going to leave it by the default. We're going to leave it the default CIDR block, which is 10.0.0/16. And also, we don't want IPv6 in this VPC, so we're going to leave it like that. I'm going to leave it. The tenancy, we're going to leave it default. Number of availability zone, let's just leave it as 2. You can go with 3, but we're just going to leave it. I'm just going to leave it at 2. Number of public subnet 2, private subnet 2, and NAT gateway. I'm going to add region or zona. Let's see. Let's put it at zona, and we need just one AZ. We need just one NAT gateway. We don't need one pet AZ. And also, we don't need a VPC endpoint. We're going to change it to none. Now, remember this option, DNS hosting and DNS resolution, exactly what we saw here, right? DNS hosting and DNS resolution support. So we need to enable this on the VPC section, which is exactly what is already enabled here. So we don't need to touch anything here. So let's just leave it as it is. Then I think that's all we need. And also, you can add a tag to your VPC, right? And if you look very carefully, sometimes if you are running a Kubernetes cluster of version lower than 1.14, you might need to add this specific tag to your EKS, to the VPC, right? But since we are running a later version, just as it is being stated here, we don't need this tag. So we're going to leave the tag there as it is. I'm going to click on create VPC. Now, creating the VPC is going to take a while. So while we wait for the VPC to be created, let's head over to the EKS session to create the EKS control plane. So I'm going to search for EKS here and go over to the EKS cluster. And you're going to click on create cluster. Now, mind you, when creating this EKS cluster, be very careful, right? There are different ways you can actually create this. You have quick configuration by using the EKS auto mode. We don't need this. Now, this is the auto mode option that's going to provision everything by you. It's going to manage everything by you. but we want to create everything from the scratch by ourselves so we can understand how everything works, and also we can have control over our own cluster. So let's click on the create custom configuration, and at this point you're going to also see that the EKS auto mode is already toggled on. We're going to toggle it off. We don't need that. Then this is where it starts, cluster configuration. Now, what is the name of the cluster? Let's just call it Barillon cluster. And we need to select the IAM role. Remember, I told you that the IAM role that we created, we need to assign it to the EKS cluster control plane that we're about to create right now. So click on the IAM role. And if you notice very well, we're going to see this is the EKS IAM role that we created. If you notice very well, if you come back to what we created here, EKS IAM role, you can see it here. This is the EKS IAM role that we created just now, right? So we're going to assign that one to this EKS control plane. So let's click on that one. And also scroll down, we're going to see, you need to specify the Kubernetes version that you want to run. By default, we have different versions here with their end of life. So we're going to go with the latest version, which is 1.34. The update policy, how do you want to update your cluster? And since this is just a demo tutorial, we don't need to click on the extended support, because anyways, after the demo, we're just going to delete the whole cluster. So we don't need extended support. So leave it at the default one. And control plane scaling tier, we don't need this as well, because this is not going to be used for any production workload. So we're going to leave it as it is. Then we're going to scroll down to the cluster access. Now, how do you want users to access your cluster? Now, you need to be very, very careful with this part, right? So the first option you're going to see is that choose whether an IAM principal created the cluster has Kubernetes admin priv access. Now, by default, the IAM user or role that creates the cluster automatically becomes an admin inside the cluster. Now, in some organizations, this is not permitted, right? And if you want to disallow that kind of behavior, you can just click on the disallow, click on disallow cluster administration access, right? But if you want the user that create the cluster to become an admin, you can just click on this one. But mind you, whichever option that you select here, you cannot revert it, because any user that creates the cluster that has been attached to the admin user in the Kubernetes cluster, you cannot remove that user anymore. So you need to be very careful, when making these choices. But in this case, I'm going to leave this one, and I'm going to leave it as it is. So Bootstrap cluster administrator access. So the IAM user that I'm using, the IAM user that I'm currently using to create this cluster automatically becomes an admin inside the cluster. And also cluster authentication method. Now, how do you want to authenticate to the cluster? So we have two options. We have the EKS API or the EKS API and config map. Now, if you use the EKS API, it means that any user that wants to connect to the cluster must create an IAM role, and that IAM role must have an access entry to the cluster. Now, don't worry about that. We're going to see all of that as we, continue with this demo. But in our case, I'm just going to select the AWS EKS API and also the config map method. Now, the config map method is the legacy way of actually, mapping an IAM user to a user in your Kubernetes cluster. Then let's scroll down, envelope encryption. We don't need to, encrypt anything. This is not a production cluster. You're going to leave it like that. AROC zonal shift, we're going to leave everything as default. And delete protection. If you don't want somebody to accidentally delete your cluster, you can turn this on, but we don't want that anyways. So let's click on next. Now, this is the interesting part, the networking part. Now, we've added the IAM role that we created in the first step to the configuration. Now we need to specify the VPC. Now, if you click here, you're going to see the VPC that we created, which is the EKS cluster VPC. Click on that one. And also, you need to also select the subnet on that VPC that you want your cluster to be, to be deployed on. Because whatever subnet that you select here, AWS EKS is going to create an ENI on those subnet in order for it to communicate with your worker node. So in this case, I'm going to select all of them, all of the options. I'm going to leave it like that. Then additional security group, we don't have any additional security groups. I'm just going to leave that as it is. You can select the default one, but I don't think we need that for now. Then scroll down and configure Kubernetes service IP address setup log. I don't want to set this. I want everything by default. And scroll to the last part, which is cluster endpoint access. Now, let me explain what this point means. Now, if you select public access to your cluster, it means that anybody that have access to the cluster or have the kubeconfig file can connect publicly to your endpoint, right? It means that if you have workers all over the world, they can connect directly from wherever they are in the world to your EKS cluster API server. And in some organizations, based on compliance, this might not be the best option, right? And because of that, we now have the private option. Now, in the private option, nobody on the internet can connect, right? Unless you are on a private, you are within the private network, which means that you need to create some bastion host or some jump server in this same VPC, and from that jump server you can connect to your cluster. And also, if you are using the private one, it means that all traffic within your worker node stays within your VPC. So no network within your worker node is routed through the internet. And also, if you are using the public one, your worker node traffic will leave your VPC to connect to the endpoint, which means that with the public setup, your cluster, your traffic within your Kubernetes worker node goes through the internet, which is not secured. And we have an intermediate access, which have the public and private. So with this, people can connect to your cluster even if they are not on the same VPC, and also your worker node traffic will stay within your VPC. So you can see some of the explanation here. So you need to also be very careful with which option that you're going to choose. For me, I believe the public and private option is an optimal solution or an optimal option that is recommended. So let's go to the next step. Click on next. And also observability. Remember, I told you that you don't have access to the master node. So the only thing that you can do is to set logins and monitoring on your master node component, like your API server, controller manager, and all of those things, which is what you can see here. Control plane logs, you can log API server, you can audit it, authenticator, controller manager, scheduler. If you want, you can log all of these. But mind you, all of these come with an extra cost. So you need to be very careful unless you actually need it. But for this demo tutorial, we don't need that. So we're going to click on next. Then after that, we also need some add-ons, right? Remember that when we created the cluster on kubeadmin, we added kubeproxy. We didn't use kubeproxy because we were using Cilium. But in this tutorial, we are not using Cilium for our CNI. We're going to be using the AWS CNI plugin for our CNI implementation. So because of that, we need kubeproxy. So I'm going to tick kubeproxy. And also we also need core DNS. Core DNS is the DNS solution within our Kubernetes cluster that helps us to resolve service name to an IP address. So we also need that. And node monitoring agent, we also need that as well. And also the AWS VPC CNI. Remember, I told you that we also need this plugin as well to assign IP to our pod. So if you notice very carefully, you know that all of these are automatically selected when we click on next. So these are the default ones that you need for your cluster to run. So we're just going to leave all of them as it is. So scroll down to next, then click on next. And you're going to see all of them, all of the add-ons that you've selected. You're going to see all of them at a go. And you don't need to touch anything, right? You don't need to touch anything. Then after that, click on next. Now, once you click on next, you're going to see all of the configuration that you've specified. You're going to see like a review. You need to review all of them very carefully to be sure that this is exactly what you want, because immediately you click on create EKS cluster, some of these options might not be changeable, right? You might not be able to change them. So be take some time to go through them, preview them, and ensure that this is exactly what you want. Then after that, click on create. Now, creating the EKS cluster takes a lot of time, right? So I'm going to stop the recording, and also I'm going to resume when everything is created. So our cluster is on an active state. You can see active here is active, and you can see some information regarding the cluster. You can see we have 0 health issues, upgrading side, everything is not just there. Now, I just want to appreciate the beauty of a managed Kubernetes cluster, right? You can see EKS gives you a lot of features, a lot of capabilities, access, observabilities, and everything. You can see them on the EKS dashboard. But if you compare this to the one we did before using kubeadmin, you don't get to see all of these features, right? You need to manage everything all by yourself. And that is why a self-managed Kubernetes cluster can be very, very difficult to maintain, very difficult to scale, and all of those things. So I, for one, we recommend anybody, any company that wants to, have their cluster provision to go with a managed service rather than go with a self-managed service. But it depends on whatever you want to do, right? If you are learning Kubernetes, we recommend you learn by using the kubeadm setup to understand how all of these components work before jumping straight into the cloud and all of that. So let's have a look. Now we've provisioned the cluster, but we don't have any compute, right? We don't have any worker node running. And if you come to the overview and come to resources, now you're going to see that all of these ports, the core DNS and the metric server, all of those ports are on a pending state. Now, do you know why they are on a pending state? It's because there's no worker node in the cluster to run these ports. So in order for us to see them on the running state, we need to attach worker nodes, and that is the step 4. That is our step 4 of creating an IAM role and attaching the necessary permission to the IAM role, and then using that to create our compute. But before then, let's connect to our cluster to see what is actually running inside the cluster. To connect to the cluster, head over to your terminal and make sure that you have the kubectl command already installed. So if you run kubectl command, you're going to see that if you run kubectl command, you're going to see that the command, the kubectl CLI is already installed on my computer or on my local machine. And if you don't have it installed yet, I will leave a link on this video to where you can install it, the kubectl command line for interacting with Kubernetes cluster. Or you can do a simple Google search on how to install kubectl. You're going to see a very, very good instruction on how you can do that all by yourself. So after that, we need to update our kubeconfig file. But mind you, before you can connect to this cluster and do anything, remember that we specified something. So let me show you something. So if you come over to your EKS cluster and you head over to the access side, you're going to see how access are being granted. Now you're going to see the IAM access entries. Remember that we specified EKS API and config map. Now what this means is that the only person that can access this our cluster as it is right now is just me, which is the IAM user that I used to create the cluster. And this is the IAM user that is that I used to create the cluster. And if you look at the name very well, you're going to see that that is the same name that you can see at this top right corner here. You can see Israel over here, and that is the user that created the cluster. And if you look at it on the access policy side, you're going to see that automatically I have granted the Amazon EKS cluster admin policy, which means that I have full admin control over the cluster, not just on the console, but inside the cluster. And you also need to understand one distinction. Now, somebody can be a normal user on the AWS account, but that person can have an admin privilege inside the cluster. So your privilege on the AWS account does not determine what access you have inside the cluster. So the cluster is a different entity, while your AWS account is another entity on its own. But in this case, I am admin on both the AWS account and also on the AWS EKS cluster. So just take note of that. We're going to explain that as we progress through the demo as well. I'm going to explain some key things that you need to know. So because of that, this user, I need to have access to this user on my command line utility or my CLI in order for me to connect to this cluster. So let's go back to the terminal, and I'm going to run the AWS STS get AWS STS caller identity like this. I think that's wrong. I think the correct command is AWS STS get caller identity. And you're going to see that currently this is the user. This is my user here that is already configured on my CLI. And this is the user that I'm going to use to connect to the cluster. Now, how do you connect to the cluster? Now, before you can connect to the cluster, ensure that the user that is currently set up on your terminal is the same user that created the cluster, number one. And number two, you need to run this AWS command. It's called, let me clear the screen. So you're going to run AWS EKS update kube config, then dash the name of the cluster. Remember that the name of the cluster, let's have a look at the name of the cluster. So the name of the cluster is, head over to the cluster, click on Barillon. You're going to see that the name of the cluster is Barillon cluster. So we're going to copy the name, go back again to your terminal and paste the name over here. I think there's a mistake somewhere. Remove that. That's the name of the cluster. And also you need to specify the region, right? The region. So we're going to specify the region. The region is US East 1 and hit enter. Now, once you hit enter, you're going to see a nice message that says add new context to this, which has been added. And if I let me create an alias for my kubectl command. So essentially what I'm doing is that I don't want to keep typing the kubectl. I just want to type k, and then it's going to run the command for me. So I'm going to run kget node on the cluster. Now when you run kget node, you're going to see that there's no resource found, right? There's no there's no node attached to the cluster. Now, whatever you see here like this, you can ignore. I think this is because there's no server, or there's no pod running in the cluster, so you're going to get this kind of error. But what you should be specific about is you can see that there's no resource found here, which means that you are connected to the cluster. And also, if you want to be sure that you're actually connected to the cluster, you can actually run kubectl get. You can run kget pods. You can list all the pods right in the cluster like this, and like always, you're going to see that error, but at the end you're also going to see your pods. And you can see all of these pods are on a pending state because there is no worker node to run these, and that is the reason why you are seeing some of these errors like this. Now you can see that all of them are on a pending state, and that is exactly what we saw here in the console. If you come to resources, come to pods, you're going to see all of them here are on a pending state. So the next thing that we need to do is the step 5, where we need to create IAM rule for our worker node and then attach our worker node to the cluster. Now let's do that. Now for us to do that, let's go back to the IAM rule session, click on rule again. Let's create a new rule, click on create rule. And the rule I want to create is not for EKS cluster, but it is for the EC2 worker nodes that are going to be attached to the cluster. Remember that the master node component is managed by AWS. The worker node is managed by you because the worker node is going to run on your own VPC. but the control plane runs on AWS managed VPC, and we created an IAM rule for those for that EKS cluster to have access to our VPC or our AWS account to create resources. But in this one, the AWS service we're going to use is going to be EC2. So click on EC2, and also click on EC2, and you're going to see different services here, right, on EC2. But we're just going to leave it for we're just going to select EC2 and click on next. Now, when you click on next, you need to specify the policies for the EKS worker node. Now, there are 3 policies that we need to assign for the EKS worker node. But before then, if you're not sure about the IAM rule that you need to attach to your worker node, you can simply go online and search for how to create Amazon EKS node group IAM rule, Amazon EKS node IAM rule. Now, if you scroll down, you're going to see some of the rule that you need to add to the EC2 instance. Now, the first one is the Amazon EKS worker node policy. Now, this AWS EKS worker node policy is what gives kubelet, right? You can see kubelet to describe EC2 instance in the VPC. So if you don't add this IAM rule, your setup is not going to work because kubelet wouldn't be able to, describe EC2 resources in your VPC or in your AWS account. So we need this Amazon EKS worker node policy. So I'm just going to copy that, copy, and go back and search for it here. You can see it is managed by AWS. So click on the first one. So we've selected that one. And go back again to the documentation. The next one that we need to select is the Amazon ECRO container pool only policy. Now, this policy or this permission will grant the EC2 instance the access to pull images from our private repository, which is ECRO. So without us manually, pulling those images by running AWS ECRO login to pull those images, so automatically those pods on our worker node can have access to our ECRO. So we specify that as well. So come and specify that. We click on that. And also, we also need another one again, which is the AWS EKS worker node policy. Now, this is important for our EKS pod identity agent that's going to be running on our cluster. Now, you might not understand what EKS pod identity means, but in our upcoming video, we're going to be seeing some demo tutorials on what is EKS pod identity and also AWS IROSA. But for now, just stick with me. And we're going to need that as well. Go back again, search for that, paste it. EKS node policy. No, I think we've not selected that one. EKS worker node post identity. Okay, so we already have that, so we can leave it. EKS worker node policy. And the last thing that we need is the Amazon CNI policy, the Amazon EKS CNI policy. Now, this is important because we need add-ons, right? Just like we use Cilium for kubeadm. We use Cilium as our CNI. In this case, we're going to be using the AWS VPC CNI add-on. So we're going to use that, click on it, and go back to the IAM role and IAM dashboard and search for it. So VPC CNI, I think we did not copy the correct, click on it, copy, let's copy it correctly. And you can see it here and select it. And I think those are the 3 rows. These are the 3 policies that we need. Then click on next. And you're going to see that the trust policy is for EC2 instance. But no other service can assume this rule other than the EC2 instance. Then scroll down, you're going to see the 3 policies that we've selected. These are the 3 policies that we need. Now, if we go back again, you can see those are the 3 most important policies that we need. We don't need anything else again. So those are the 3 policies that we actually need for this setup. So click on create rule, but there we need to give the rule a name. Let's call it EKS worker node role and click on create role, and that's it. Now, once we've created the role, the next thing that we need to do is to create the node group. Now, let's go back to our EKS cluster. Click on, this is the EKS cluster. Click on your cluster and head over to the compute section. And this is where you can now have your nodes, your node group, and your Fargate profile. Now, your node group gives you the flexibility of specifying a particular configuration for your node, and any node that comes from this node group already have that configuration already configured. For instance, if you want to configure like 20 worker nodes and you don't want to manually configure them each, you don't want to manually configure each and every one of them, you can create a node group and configure the node group, and all the nodes coming from that node group are going to have that specific configuration. But if you want to create your node individually, right? I don't think you can actually do that, but yeah, this is the recommended way. So click on add node group, give the node a name. Let's call this Babylon node. Now you can have more than one node group, right? Depending on what you are doing. Maybe you can say this node group is for running maybe your backend pods. The other one is for running your front-end pods, or you can have node group for maybe you are running machine learning stuff, machine learning model on your cluster. You can say this one is for AI models, this one is for normal workload, this one is for bash workload, right? There are different ways you can actually specify that. But in this case, let's call this Babylon node, and the IAM role we're going to select, you can see that it automatically highlighted the EKS node that we created. EKS worker node role. That is not selected. There's something wrong. I think we made a mistake. We still have EKS node group rule here. Let's have a look to why is this node not selected. Missing required policy, Amazon EC2 container registry read only. I think we have some missing permission that we need to add to the IAM rule in order for us to select it here. Now, this is the beauty of doing a demo, right? So this is the beauty of doing an hands-on, so you can actually understand what needs to be done, right? Doing a project and you're just getting everything, you're not getting stuck, then you're not actually learning anything. So let's go back and see what the problem is. Now let's go back to our IAM rule and see what is there. We said EKS worker node rule. Let's click on it. Now, what is the problem? Now we have 3 policy here. And go back again to the EKS cluster, and if we click on that, we can see missing required policy, Amazon EC2 container registry read only, and Amazon EC2 container registry pool. Okay, read only. We also need the read only as well. We also need read only as well. Yeah, we need read only. So we need to add that permission as well. So let's go back and add that permission to the cluster. Let's copy that because we're going to need something like that. So let's go back to add permission, attach policy. Let's search for that policy, the read only one. We have pull only. So we need to add read only. And this is the one, the read only one here. Click on it and add permission. So we've added the permission, and let's go back again and see if we can select it from here. Refresh. Make sure that whenever you change something there, you need to refresh it here. So if you click on the drop-down menu, you can now see that we are able to select it. You can see that EKS worker node role is here already, so we're going to select it. And scroll down, and yeah, once you scroll down, you're going to see if you want to add a label to those nodes. Remember that whenever you create a cluster or you created a worker node, depend on what you want to do, right? You can label your nodes, you can tint your node, you can even tag them, right? So it depends on what you want to do. But in this case, we don't have any specification to do that. So we're just going to leave it like that. We're going to scroll down and create. We're going to click on next. So here we need to specify the AMI that we want to use for our worker node. There are different AMIs here. You can use Amazon Linux, you can use Ubuntu images, Ubuntu servers, or Amazon Linux. So I'm going to leave it as the default. And also capacity type, do you need on-demand or spot? Now, on-demand, you are guaranteed of your worker node. But if you click on spot means that AWS are going to give you some nodes at a very cheaper rate. However, you don't get guaranteed that those nodes are going to be yours. A moment, you can see your node running. Another moment, AWS can just take away those nodes from you. So run those applications that time doesn't actually matter on spot instances, so that even if they get taken away, it's not going to affect your business, right? So we're going to click on demand, and instance type, we're going to go with T2 medium. Let's click on T2 medium, and yeah, click on T2 medium for our worker nodes, which is, and also for our disk size, let's just leave it as 20 gigabytes. You can inflate it if you want, but obviously we're not running much in this cluster, so we're going to leave it like that. And also for your auto scaling, because your node group works well, or it integrates with the AWS auto scaling group, so you can specify the desired number of node that you want, and also the minimum size and also the maximum size. So the desired size is the amount of node that you're going to see once this node group is created. Minimum size is if you attach auto scaling group, the minimum size that you can have, the minimum number of worker node from this node group that you can have, and also the maximum one that you can scale up to. So I'm going to leave it in 2 flat. I'm going to leave it 2 to 2. I'm going to leave it like that. Then I think that's all of this. You can just scroll down and click on next, and which subnet that you want to launch your EC2 instance on. Now I'm going to spread them across all the subnet that we have. Remember that we have 4 subnet, 2 private and 2 public subnet, right? And also there's another option that tells you to configure remote access to node. Now this option is needed if you want to connect to your node. Maybe you want to, your node have issues, you want to connect to see what is there. Maybe kubelet is your disk is getting filled up. You can just log in, but we don't actually need that in this demo, so I'm just going to toggle it off, right? You can experiment with it if you want. Then click on next, and you're going to read everything, make sure everything is fine, and then you click on create. Now this is going to take some time to get created, so I'm going to pause the video and I'm going to resume back when the node is already created. So let's confirm if everything is working. So we're going to refresh here the dashboard, and you're going to see that creation failed. Something happened while we are creating the worker node. So let's click on the health issues and see what the problem was. So you're going to see that for node group, Babylon node does not automatically assign public IPs address to instances launched on it. If you want your instance to be assigned a public IP address, you need to enable or to assign public IP address to the subnet. That is because we did not specify the option of auto assign public IPs, because we need our nodes to have public IP. We need to enable or to assign public IP on the subnet, so that any node that gets created on that subnet automatically have an IP assigned to it. Now we can confirm that on our VPC. Click on your VPC, and this is how we created our VPC previously when we started the video. Click on my VPC and click on the VPC we created, and this is not the one we created. This is the default one that comes with AWS. So refresh, and this is the one we are looking for. Click on it and go to, these are the 4 subnet. Now let's have a look at each and every one of the subnet. Now let's click on the first one. If you click on the first one, you know that the auto assign public IP is not enabled. You can see it here, auto assign public address is no, which is the issue we are having here, which is we need to enable auto assign public IP. So in order for us to change that, click on action, click on edit subnet setting, and toggle it on. Now we're going to do this for all the subnet. So this is for the first one. Let's exit there, go back to the second one, click on the second one again, go to action, edit subnet setting, tick that to be, check that to be on, go to the next one. I'm going to do that for all of them. Go back again, go to edit subnet setting, enable it, and click on save. Go back again to the last one and action, subnet setting, check that to be on, and save. Now you can see that everything has been, we've enabled or to assign public IP on all the subnet. And let's try again with our node and go back to the cluster and compute. This one already failed, so we can as well delete it, but let's create new one first and we can delete that one. Let's go over again, type, let's still call it Barillon node. Let's call it nodes, because if we say node, it's going to conflict with the other one we have there and it's not going to work. So leave it like that. Let's go over the process again, click on next, leave everything on demand, EC2 instance. Let's search for T2 medium, and that's all we need. And disaster, leave everything as it is, and then click on next, leave all the subnet as it is, and click on next. So click on create. So let's go back again and delete the previous one that failed. Compute the previous one that failed, this one. Let's delete it. Click here and click on delete, and Barillon node. Click on delete, and yeah. So we've deleted the previous one that failed and we're waiting for the new one to be created. And obviously this is going to take some time. So again, I'm going to pause the video and resume recording when everything is done. So we can now see that everything is good. We can see our node group is on a ready state. You can see it is active. And if you scroll up to the node, you're going to see those two nodes as being provisioned and they are on a ready state. So we've successfully created a cluster. We've added worker node to the cluster. And if you go back to your pod now, you can now see they are on a running state. You can see that all of them are running here. They are all running. And if you notice very well, previously we had some few pods, right? Some few pods called DNS, the metric server, and some other pods. But now we now have some other nodes that are there now that are running. Now the reason is because most of those nodes, like this EKS node monitoring, they are all daemon set, which means that if there's no node, you're not going to see them, right? They are deployed based on the number of nodes that you have in your cluster. Now let's go back to our CLI and see what is actually happening. Now, since we've added two nodes, if we now run kget, let's clear our screen and let's do kget nodes. Let's expand it to see what's there and hit enter. Now you're going to see that the previous error we were getting, we are no longer getting that error anymore. We can see everything at a glance. Now let's remove that while so we can see everything clearly. So kget node. Now you can now see that we have two nodes. Now these are the two nodes that we added on that node group, and you can see they are in a ready state. And if we also do kubectl get ports and everything inside there, we're going to see all the pods that are running in the cluster. So we've successfully created a cluster, we've added node, and now we can deploy our application, right? We can deploy our application and then expose it using the AWS load balancer controller. That's all for today. Please, if you've not subscribed to my channel, do well to hit the subscribe button and share with your friends. It was getting a little bit on the longer side, so I decided to make it short and continue in the next video. Take care, and I'll see you in the next video.